I would die.
Don't worry.
It's so funny because I'm very
All right,
So you're gonna say that out loud. Here we go.
so we're gonna go ahead and continue talking about net distance or displacement and total distance, okay? So, the formulas that I'm gonna give you here will work as long as they provide you with the position function, okay? Most of the time on the UP test, they might not provide you with the position function, but sometimes they do, and you need to know how to work with it, okay? A lot of the times they do give you the velocity function, so you need to do a process called integration to be able to find the total distance and the net distance because they're giving you the velocity and you want to go back a function. So integration is like finding an antiderivative. You're going backwards, you're undoing the derivative process. Yes? So for now, we're going to be using these formulas that I'm giving you, but eventually when we learn how to integrate or find antiderivatives, we will use those different formulas because most of the time they will provide you with a velocity function. Okay? But for our assignment and for our test at this moment in time, if I ask you something with total distance and displacement, I will more than likely provide you a position function. Good? Alright, so anyways, here we go. Let's see, how to find the net distance or the displacement. Right, so let's say on an interval from A to B, the displacement is just simply found by doing the absolute value of my initial position P of A minus my final position P of B and getting the absolute value of it. So finding out where I am, where was my initial position, and then finding out where my final position was, subtracting those two numbers, and then getting the absolute value of it to make it what?
Positive.
Positive. Could I also do P of B minus P of A if I wanted?
Yeah.
Yes, let's say I'm so used to the formula for a slope and I want to do y2 minus y1, right? Okay, so if you made that mistake, it would still work. As long as you make your answer positive. What should the units be if I'm finding distance? Like meters, centimeters, feet. They're not going to be meters per something, right? We're not finding rates, we're finding distance, right? How long something, how far it traveled. Alright, so what could we say about the total distance if the particle only traveled in one direction? It would be the same as the what? As the displacement. Do you want me to write that down? It's up here, right? We wrote it? Right? So if the particle, I guess we could highlight it.
Yeah.
So if the particle is moving in the same direction for the entire amount of time, we know that the total distance should equal the what? The displacement, right? Or the net distance. Just to try and save time and not have to write that again there in that little box. Is that okay? I can rewrite it for you if you want to have it there. So we would use the same formula that I have here as long as the particle moves in the same direction. How would I know that the particle is moving in the same direction the whole time? The velocity, okay, that's the right start. Very good. The velocity would always have to be positive, Ricky, or always negative. So how could I determine that? Making a sign line, right? Finding the derivative of the position function, right? I would also probably want to find out where the velocity is what? 0, because that would be like a critical number, right? Okay? Put it on my sign line and then check the intervals, right? What if it were like positive, then it stops, and then positive? So did it continue in the same direction for the entire time?
Its distance didn't change by just
It was
stopping.
positive, then it stopped, and then it continued positive. So could we technically say that it traveled in the same direction for the entire interval?
Yeah.
Yes, or would I have to split it up into two different intervals?
I mean, you wouldn't have to because technically, by stopping, you never really.
Right.
Yeah, stopping didn't add distance.
So would I have to figure out the distance from A to B plus the distance from B to C even though I was going in the same direction? No? No, I wouldn't in that case, right? But if I did change directions, then it would matter, okay? So then I would have to add from A to B, figure out how far I traveled in that direction, plus from B to C, figure out how much I traveled in that direction, and then add those two distances to find the total distance traveled. Do you understand? The particle may have moved one way and then moved another way, but I want to find out how much it moved in total. Good? Alright, so here, if the particle changes direction at some time t equals c on the open interval a to b, then the total distance is the absolute value of P of A minus P of C plus the absolute value of P of C minus P of B. It's kind of what I was describing, okay? Except C is the time where the particle stopped and changed direction. C would technically be where the velocity was what? Was 0, right? You understand? I want to find my position from where I started to where I stopped, plus from, and that's where I stopped, but then I started moving again, right? To where I finally ended up. Assuming that in this interval they were always traveling the same direction, and in this interval traveling another direction. And then I add those two distances. Seems easy? Yeah? It's actually really easy. The hard part is finding out whether it's traveling in one direction or not. But we've already done sign lines, right? We've already done sign analysis, so it shouldn't be too bad. We've already done derivatives. So let's give it a try, okay? We'll do 3 examples, and hopefully that should be enough. If you want me to do more, I can do more. What do you think? Give it a try? Alright, so it says the position of a particle is given where P of t is measured in what? Centimeters. So they're giving me position and it's measured in centimeters. Remember the units. Find the net and total distance the particle travels from time 1.5 to time 4 seconds. Okay, so let's find the net distance, because that's easy. That's equal to the displacement, right? And that would just be the absolute value of what? The difference between my starting point and my ending point, which would be P of 4. And figure out what that is. So this is where your calculator will come into play. There's many ways that this can be done. Let me show you one way that I thought was kind of cool. And then you decide whether you like it or not. Okay? Ready? So what I'm going to do is I'm going to first enter this function into the calculator under a graph page. And I'm going to pay attention to which function it is. So on mine it's F7. I don't know what it's going to be on yours. Okay? So I'm going to enter 2x to the third minus 6x squared plus 8x. I'm going to press enter. Cool? Mine was F7. Remember what yours is, okay? Now what I'm going to do is I'm going to open up a calculator page and I'm going to use that function that I already put in there to evaluate it at different places. Anybody remember how to put the absolute value?
Next to the little Bible.
The button next to 9, right? Okay. So the button next to 9, and it should be those two vertical bars there. So the absolute value, and now what we're going to do is I'm going to enter the function that I've had it saved as. So I'm going to go to vars, the button on top of 9, and I'm going to pick F7 because that's the one that I used. So I'm going to do F7 at 1.5, minus vars F7 at what? 4. And bam, it gives me the answer. Pretty cool? I don't have to store the numbers and I don't have to find out what they are and then subtract them. I could just technically store the equation, right? And then use that equation to evaluate. Pretty good? So here we get 58.75, and what would be my units? Centimeters, because it's a displacement. Huh?
Yeah, 6 feet would be. We are using sig figs? No. Are we okay? Displacement pretty easy? Do you like that method or no? Typing it in like that? Yeah? That works, right? That saves us a little bit of time? I think. Was everybody able to do that? Remember vars? Okay, if you're starting from scratch, there shouldn't be any functions, so more than likely it'll be like f of 1, right? And when you click vars, it'll be the only one there, so it actually makes it even easier. Okay, cool. Now we want to find total distance, so what do I need to check for first? Check to see if the particle changes direction. Okay? By using what? The velocity sign line. Okay, to make a velocity sign line, I need to get the derivative of what? Of the position. Okay, so what would be the derivative of the position? 6t squared.
6t squared
Minus 12t plus 8.
minus 12t plus 8. Alright, what's up? No, I didn't bring food. Where are you going? To Chick-fil-A? Okay. How much is it? Like $7? Or 8?
Not, like, I'll be there then myself.
Okay, I'll give you 8.
Yeah, okay. I'll tell you how much it is.
Okay. Number 1.
Number one.
Yes. Extra pickles. And a Fanta. Regular, medium.
I love a man who knows what he's doing. Fanta.
Fanta. Alright, so, did you figure it out? When is the velocity equal to 0? Factor it.
Oh, you got it.
Do something.
Yeah.
How can we do this? Is it factorable? Yes, I will try it. What can we take out? A 2? Okay, so if we take out a 2, what are we left with? 3t squared minus 6t plus 4? Alright, so is that factorable? 3 times 4, that's 12, right? But we want a negative 6. So what times what gives us 12 but combines to give us negative 6? 4 times 3, no, that's 7.
Is it calculator?
No,
I always know if you don't write it on
What is
paper,
it called?
it's not right.
if I don't write it on my paper, it's not possible.
Yeah.
Oh, you're learning, you're learning.
Quadratic?
Quadratic
This is quadratic formula, sir.
Quadratic formula?
It's in non-calculated section. It's non-calculated
X
section.
equals negative b.
Plus or minus square
Good job.
b squared minus 4ac all over 2.
Awesome. So you want to do it? Alright. Alright, so x equals negative negative 6 plus or minus a square root. Negative 6 squared minus 4. A.
Wait,
C.
6 is not. 6 is not.
All over.
6 is not.
through A.
Wait, it's 6?
6 is B.
Negative 6.
6 is B if I'm using the factored one.
Oh.
If you're using this one, then B would be different, right? But I would rather work with smaller numbers. Yeah? So we get 6 plus or minus the square root of what?
36
36 minus
minus
48,
48.
negative
12?
12?
Yeah.
Okay, divided by 6.
6 cancels out.
You can't have a negative in there? Oh man, so why didn't we just do this part inside to figure out if we had a negative in there and save us some time?
All
Anybody
the
know what that's called?
discriminating,
The discriminant, yes.
Oh, yeah.
Okay. So remember, if that was 0, then there was 1 x-intercept. If it was positive, then there were 2.
Yeah,
Right.
yeah.
If there was negative, then there were no real ones. They're just imaginary. But we don't want to travel to the 4th dimension right now. Okay.
Maybe tomorrow.
We'll just stay here.
Sir, maybe tomorrow.
Maybe tomorrow we'll travel to the land of the lost. Do you
Yes,
remember
with
that?
Chaka.
Oh my god.
Chaka?
What?
Chaka will help you. Get lost.
The movie's so good.
It smells weird. Did somebody spray some?
Sorry.
Where's your science party?
Yes, I farted. I'm sorry.
Oh, remember the part like, do you smell popcorn? And everyone's like, and they're like, oh. They do that to me all the time. It's like, did you make popcorn? I'm like, no. I'm like, oh.
Interesting. All right, so